Hi, and welcome back to the digital job site. This is part two of a two-part blog post that I'm doing on findhomebuilding.com titled Begin with the End in Mind for Shed Design and Layout and Floor Framing. And in the first part, part one of the two-part series, we talked about why the layout is such that it is to accommodate the seams in the siding, etc. Talked a little bit about how to do floor joist layout, etc. And this video just want to go over briefly the assembly process and principles of squaring up the subfloor, or squaring up the floor framing to put the subfloor on. So we're going to turn some layers off here and get down to the part of the model that we're going to discuss, and that will be the floor framing itself. And all you're looking at here is 2x6s used to frame this up. If I turn off the floor framing, we're left with nothing but a couple of 4x4 sleepers, or a foundation more or less in this case, and a bunch of dimensions. I'm going to assume that the site where you'll be building a shed is relatively flat, and that would to accommodate the shed being built flat, a person would need to have an area roughly 8 feet square, and have it level. And it could do that by cutting these 4x4s exactly 8 feet long to start off with, and then laying a 4-foot level on the top of them. A person could turn the two 4x4s 90 degrees and re-level them, and that would make an area that was level enough. Some of the the video series on fine home building for the tool shed and the garden shed, I believe those go through the process of using concrete blocks buried in the ground to establish a level platform for building a shed on it. But to keep this video simple, I'm just going to assume that you're working with an area that's flat enough, and with that privilege or advantage, a person can just lay 4x4s down on the ground, put the 2x6 framework on top of it, and then square it up. So that's kind of what I'm going to talk about here. When, oops, not the subfloor, let's take the floor framing. So I've got this geometry grouped here, so I'm going to explode the group and take one of these members here, the rim joist, and although I have the move tool, it keeps coming up with that rotate icon that I don't really want at this point. I'm just going to slide this one over this way 96 inches, and if you're doing layout work, you've probably seen this already. It's nothing new, but carpenters tend to use hash marks. I'm going to create one here. I'm just going to draw an 1.5-inch line, and then I'm going to draw an X on it like this, and we're just going to make this little thing here. So I'm going to delete this little thing first, then we'll take this and make it a group. And what this would be is a typical layout mark. And I explained in the first video that starting at the end of a structure, you want to make sure you have your layout centers going to the center of the first member. In this case, it's 16 inches, but the first layout line goes to 15.25, and then these are moved over or copied, laid out with a tape measure. Oops, I missed my target there. These are just moved, laid out with a tape. We're going to go 16 inches, enter. Let's go 5x, enter, and zoom out. You can see we ended up with an extra one down here at the end, which we don't need. But that's what the layout looks like. If you were to lay out these plates, I would just make the layout on one of them and then transfer it to the other board, And that's typically what a 16-inch on center layout would look like. Line up the edge of the board with the line, and then the member falls on the X side of the line. So I'm going to take that. And let's see, I'm going to delete that. I got a little clumsy here on my process. As you can see, I didn't work this out before doing the video. So I'm selecting and deleting things. Okay, so now I can take this and the marks. I'm going to make a group out of that. And I'll just copy this group over to the other side. Looks like I included a 4x4 in my group, so I'm going to explode that and delete the 4x4 out of it. Okay, what I was showing you there is rather clumsily, but the way to do layout, just by pulling a tape measure, drawing a straight line, squaring it up across the two rim joists, and then separating them. All the joists in here are cut to the same length, and we want to end up with 96 inches of total width to fit our plywood and siding, etc. So the joists are cut at 93 inches. If I take these joists out of here, it kind of shows the process, and I actually put nails in the end of these joists, made little nail components, so that you could see a typical nail placement. The 3 nails is good. It keeps that board from twisting, and this nail should be 3/4 or an inch from each end. Those nails driven straight in to get the best holding on that floor joist. Another thing that you'll want to make sure you do is, while on the digital job site the lumber is perfectly straight, in the real world lumber almost always has a crown to it. When you eyeball it down, there's a hump in it in this direction. Put that hump up, the crown up, so that then when weight is put on the floor, it straightens out the lumber. If you put it in crown down and add a load, it just makes the sag worse. So we would just take and nail joists in on each of the marks. Just going to move one over here. This is where the digital job site's a great thing, because I can just say 4X, and I have all the joists in them, and you can see what I did there is I moved that joist over 15 1/4 instead of 16 inches. So I'm going to back those off. We'll move the first joist, move it and copy it, the layout, and then I'm going to move and copy again. The first one, move 15 1/4. The rest of these will be 16 inches. And we'll go 4X, enter. And then we take one more copy and move it out to the end. So you can cut these boards. Make sure that if you buy an 8-foot 2x6 at the lumber yard, chances are it'll be 8 foot and a half inch or 1/4 inch. So trim up and square up the ends and make it exactly the dimension you want. In this case, 96 inches. Same thing with these center joists. Make sure they're all cut accurately. And you'll have this floor framework set up. I'm just going to regroup this. See if I can select it by pivoting around. I got all those joists, and I don't want to include that measurement. So by holding Shift, I can delete it from the selection. Right click and make a group. So in this case, this I have this floor joist assembly, and it's equal width from one side to the other, and the two rim joists are the equal length, but the whole thing might be it might not be square. And so I'm just going to do a quick demonstration here of how what square works like, and show you this. I can't do it with that group of components because the way the geometry is set up, it wouldn't behave. So I'm just going to draw this quickly. Let's see, 4x, enter. 3x, enter. Okay. I could have drawn this ahead of time to save time on the video, but I did not. This way you get to watch me fumble around and draw a little bit. I'm holding shift, selecting these areas and getting rid of it. Okay, so now we have this little bit of geometry, and you can see that it roughly represents the top of these floor joists. So I'll put a couple dimensions on here. So this is the actual dimensions are irrelevant. I'm going to show how it's squared. You can see when it's squared up. So there's the width and length, and then we'll click a couple diagonals here. We have to make SketchUp behave so that it goes on the diagonal. But drawing this stuff on the digital job site, everything comes out exactly square the way we drew it. But as I was describing there, if just because the two sides are equal length, the diagonals might not be. You might have a parallelogram, and I can demonstrate that with the move tool here. So if I shift this, you can see that although the 89 and 7/8 stays the same, the diagonals are different by almost 10 inches, and that's an odd square situation. So once this is shifted into space, it the whole assembly ends up square. The other thing, if the joists weren't cut the same length, you would have a situation like this. And let's see if I grab the right tool. I did. So this is another way it can be off and out of square if the floor joists weren't all the same length. So with that in mind, after you've built this assembly with the rim joists, 4x4s, and floor joists, it might not be square. And I'm not really going to get a true indication of what that looks like by sliding this floor joist, because it's not really connected the same way. But I guess maybe it demonstrates a little bit more what I had in mind. You can see how the diagonal dimensions are becoming unequal. So when your floor assembly is all put together and nailed up, you could stake one side of this down to the dirt with a couple wooden stakes and slide the other side back and forth until the diagonal dimensions are equal. Then you know it's square enough to put the plywood on it. So I'm just going to delete this batch of geometry here and show the subfloor. I put both sheets on at the same time, so I'm just going to temporarily delete one of these and show that when the floor assembly is square, looking down on the top, the plywood will line up with the two end joists, and it can be all attached down, whether you decide to use screws or nails or glue or all three or a combination thereof. In the middle here, something that won't show up in SketchUp, but each floor joist can have a side-to-side bow in it. So the proper way to install that plywood is to start on a straight edge and line up the edge of the plywood with the rim joist and nail it all along the edge. And then you can move to the end and straighten out the joist, bowing it in and out till it's flush with the edge of the plywood, and then fasten that edge. And then by hooking a tape measure here and going 15 1/4 to the first joist, and you can just go, you can start here at 15 1/4. The next one is going to be 31 1/4, 47 1/4, and so forth, and all the way down to the other end. It should end up with a total of 96. But if you straighten out one on the end and then line up the other joists in the middle to their 16 on center locations and nail them down, then all the floor joists will come out straight across and accurate, And this will also reconfirm the squareness of your floor joist assembly. And once those things are all done, let's see, I'm just going to use my back arrow. Hopefully, once that's done, I would nail along this edge of this sheet and make sure that the rim joist here and the corner of the plywood line up on this side, and then nail, drive the trunk and groove plywood together and nail each subsequent joist. When you get over to this corner, everything should be all nice and flush and straight, and you'd have a sound and solid flat deck surface. You might want to recheck it at this point to make sure that one of the corners hasn't dropped or whatever, and make the deck surface out of level on one of the sides or another. But after that series of steps, you should have a very square and very level and flat floor framing, sheeted floor framing assembly. And from there, you're ready to go to the next step, which will be to snap some lines and do some wall framing, rafters, fascia, soffit, siding, roof sheathing, ice and water shield to get it dried in, shingles, ridge cap, doors, windows, trim boards, and finally the decoration and final inspection. I'll do another blog post in probably 1 or 2 segments. The next one will be to show steps for doing the wall framing. So if you stay tuned in a week or so, when I can get that video put together, I'll do that. We'll go through the steps for framing the walls. And as you can see here, these studs don't run all the way up to the rafters. They're interrupted by these plates. It makes it a little more simple to frame and to understand, but I'll also cover alternate methods to balloon frame these gable end walls so that the studs go all the way up and you don't have this extra set of plates in here. But that'll be covered on the wall framing segment of this shed building tutorial. So I hope that's helpful, give you some insight. Again, I'm trying to make this an interactive building process, so if there's things that I've left out of the description and tutorial, or if there's questions or options you might want to look at, post those as comments on the Digital Jobsite blog at finehomebuilding.com under the Begin with the End in Mind blog post, and I'll try to address those and incorporate comments and questions into the future videos in this series. But for now, I appreciate you coming to the Digital Jobsite and checking out this process. Thanks for watching.